Hello everybody, welcome back to Chapter 5 Reading Guide for Campbell's Bio textbook. In the last part, obviously I went through questions 1 to 10, but I think, or not 10, at least 11. But I forgot to mention question 9, so I'm going to go through this question, but then also a small update. I'm not going to make these videos really long, make them short, have some storage issues. So I'm going to make them short, but I'm going to be consistent with these uploads so that you guys can understand this, so you guys can learn this stuff. So yeah. So most monosaccharides are some multiple of CH2O. For example, ribose is a 5-carbon sugar with the formula C5H10O5. That's what makes it a pentose sugar. Penta means 5. That's why you have 5 carbon atoms, as you see right here from my cursor. What's the formula of an hexose sugar? Hexose sugar means that it would have 6 atoms of carbon, right? Mentioned here, C6H12O6. That's your formula for glucose. It has 6 carbon atoms. Right, and yeah, that's hexose sugar. Other examples of hexose sugars are galactose. Galactose literally has the same formula as I mentioned here, C6H12O6. The only difference between glucose and galactose is their structure. They're structured differently. That's why they're given different names, despite the fact that they have the same formulas. So question 10 and 11 went through the last part. Let's go to number 12. So this right here is the abbreviated structure of glucose. This is the structure of glucose monosaccharide. It's a hexose sugar. Obviously what that means from the previous question that we just reviewed, it has 6 carbon atoms. So you can obviously understand how the carbon atoms are labeled. I mean, they're not labeled. You can understand where carbon atoms are on a carbohydrate based on these numbers: 1, 2, 3, 4, 5, and 6. These unlabeled corners represent a carbon. So 1 is a carbon, 2 is a carbon, 3 is a carbon, and so on. So anytime you're reading a carbohydrate monosaccharide, if you know these numbers, then you know the carbon's there. And obviously, carbohydrates are made up of carbon, hydrogen, oxygen, as I mentioned before, in the previous video at least. So you can see how there are hydrogens here. H represents hydrogen, and O represents oxygen. These have there are oxygens, and that's what makes it the carbohydrate monosaccharide. Yeah, and then this is a glucose diagram. Question 13 focuses on the circle number 3 carbon and put a square in the number 5 carbon. So question number 3 carbon, you have the hydroxide on top and the hydrogen below. And the number 5 carbon, you have the hydrogen below and you have CH2OH on top. But then it's only set to put a circle and square. I was kind of lazy to do that, kind of lie. Alright, so number 14, let's look at our reaction to question 7. So question 7 was, if you go to the previous part, you can see question 7. C6H12O6, C6H12O6, and then C12H22O11 plus H2O. Notice that 2 monomers are joined here to make a disaccharide polymer. 3 important disaccharides have the formula C12H22 and O11. Name them following chart. So, disaccharides, you can technically consider them as carbohydrate monomers, except polymers. Polymers are made up by monomers. Polysaccharides are made up by monosaccharides. Disaccharides are made up of 2 monosaccharides. So here we have glucose and fructose. That makes up sucrose. Sucrose is technically right here, C12H22O11. And it's made of, and if you think about it, fructose also kind of has the same formula. Not kind of, it does have the same formula as glucose, but it's again structured differently, just like the previous example of galactose and glucose. And you can find these in fruits. Cellobiose, I hope I pronounced it right. Cellobiose, okay. 2 glucose molecules with a 1 to 4 glycosidic bond. So 1 to 4 is technically a linkage between the it's a glycosidic linkage between 2 different carbohydrate monosaccharides. It is between the number 1 and number 4 carbon. Obviously, remember how we labeled carbons based on numbers? Like that, here 2 glucose molecules are bonded, 1 from the first carbon to the 4th carbon of the other glucose molecule. And that's what creates cellobiose, is your disaccharide with 2 glucose molecules, 1 to 4 glycosidic bond. I want you guys to remember, if you're anytime bonding, if there's a bondage between carbohydrate monomers, monosaccharides, they're called glycosidic linkages. And that's that's your link between carbohydrate monomers. And this is found in honey. Trehalose. Trehalose it's again 2 glucose molecules, but then it's with a 1-1 bond. So that means the first carbon of 1 glucose molecule is bonded to the other first carbon of the other glucose molecule. That's the glycosidic linkage between the first carbon and the other first carbon. And that's what creates trehalose, and that's found in plants. Notice the difference. The linkage between the carbons are important in determining the element. Obviously, 1 to 4 gives a cellobiose with 2 glucose molecules. 2 glucose molecules might come together, but then if they're bonded to 1, like the first carbon to other first carbon, it's going to give us trilose. And number 15, have you noticed that all the sugars end in OSE? Sugars end in OSE. Like obviously, you see here, right here, trilose is a sugar, sucrose is a sugar, glucose is sugar, fructose is sugar. This root word means full of. O's, like sugars, like are mainly in carbohydrates. OSE is going to be in that category. And yeah, like I mentioned before, glycosidic linkage, a disaccharide consists of 2 monosaccharides connected by glycosidic linkage. For cellobiose, it's obviously 1 to 4 bond for the first carbon and the fourth carbon, but the two glucose molecules. And trilose is going to be the first carbon and the first carbon. In the next part, we will go over more of these questions from 17 to others, and this is like cis and trans. It's like, yeah, it's the 1 to 4 glycosidic linkage I was talking about. See, there's number 1 right here. That's the first carbon. That's the fourth carbon. Obviously, we label carbons based on the numbers. First, new, fourth, and then first, new, fourth, and continues so on. That's your first 4 glycosidic linkage, and that's how it goes. And yeah, in the next part, I'll go through more of these questions. But hey, thank you for watching. Appreciate it. See you in the next part, man.